Hello class and welcome back to our video lessons on mass, weight and density. And today, this is the final part of this chapter. We're going to look at part 5 and we're going to talk about how density can help us to explain floating and sinking. Now, if you remember, density tells you how dense or how packed an object is. If an object has high density, that means that object is very packed. There's a lot of mass within the object. If the object has low density, that means it's not very packed. There's not a lot of mass within the object. Now, to explain floating and sinking, this is actually quite simple. We can explain it with density. Basically, when an object is placed in a liquid of lower density, the object will sink. When an object is placed in a liquid of greater density, then it will float. Okay, so here I have a simulation that shows you how floating and sinking works and how we can use density to explain floating and sinking. So here I have a wooden block, and this wooden block has a density of 0.4 kilograms per liter or kilograms per meter cube. Okay, now if you remember the density of water, so water has a density of 1 kilograms per meter cube or 1 kilograms per liter cube. So if the object has less density than water, less density than 1, that means the object will float. If the object has more density than water, his density is higher than 1, then it will sink. So this wooden block, it has a mass of 2.3 kilograms, okay? But that's not important. What is important is its density. Its density is 0.4. So will this block float or sink? We will see. So the block floats. Why does the block float? It's because it has a lower density than water. Water has a density of 1. This wooden block has a density of 0.40. Let's try this. This is a brick block, and the brick block has a density of 2. Don't worry about the mass. We are only looking at the density. 2. 2 is bigger than 1. Will this brick block float or sink? So we will see. It will sink. Why does it sink? That's because it has a higher density than water. Water has a density of 1. This brick block has a density of 2, larger than 1. So it will sink. Okay, so now I have two objects here, and they are both made out of wood. And you will see one is smaller than the other. One is quite heavy with 4 kilograms, and the other is 2.3 kilograms. So my question to you is, which one will float and which one will sink? So let's look at B. Will it float or will it sink? It floats. What about A? It also floats. Now, this is a very important part about density. Even though the masses and sizes are different, both of their density are still the same. Density is a property of the substance. These two are made from wood, and all wood, regardless of size, whether it's big or small, have the same density. So this type of wood will float on water. So regardless of the size, so if I make it small or big, it will still float. So density is a property of the substance. If the substance is the same, the density will also be the same. Okay, so here again, I have styrofoam. One is 1.5 kilograms, and it's a very big styrofoam. And the other is the small styrofoam. But they're both styrofoam. They both are the same substance. Both of them have the same density. So both of them will do the same thing when you put them in water. They will both float. Now in this example, I have two substances. A is wood, and you can see it's very heavy. It's 4 kilograms. B is aluminium, but is lighter than A. It's 2.7 kilograms. Which one will sink and which one will float? So let's do B first. Will it sink or will it float? It sinks. What about A? Will it sink or will it float? It floats. Now, in this example, it shows you that mass doesn't matter when it comes to floating or sinking. Only density matters. You can see A is heavier than B, but A floats and B sinks. That's because A, which is made out of wood, is a material that has a low density. It has a density of zero point 0.4, you can see here. Whereas aluminum is a type of metal, even though its mass is smaller, it has a higher density than water. Its density is 2.7. That's why it sinks. So only density matters when it comes to sinking and floating. Okay, so hopefully that shows you how we can use density to explain floating and sinking. So example 4 shows you another situation where you can use density to explain floating and sinking, but I am not going to go through this. You can just read it through your notes and read it through the slide and copy it down in your notes. Now let's talk about the consequences of density in real life. Let's talk about ice cube and icebergs. You can see ice cube is smaller than an iceberg, but these two things can float on water. So water is a strange substance. It expands when it is cool. So the volume, the size becomes bigger as you cool it down. This means that when water turns into ice, its volume increases, but its mass stays the same. Therefore, as the mass stays constant, but the volume increases, the density decreases. So if you remember, density is equal to mass over volume. Now for ice, its volume is increasing while the mass stays the same. So what's going to happen to the density? Now you can do this using rough calculation. If the denominator of a fraction becomes bigger, the fraction becomes smaller. In other words, the V becomes bigger, the density will become smaller. Now, because the density decreases, ice has a lower density than water, and because it has a lower density than water, therefore ice floats on water. Now, even though ice and water, they are basically the same substance, but because ice has a slightly bigger volume than water, so ice floats on water. The next part, submarines. How do submarines float and how do submarines sink down into the water? You can copy this part down, but I'm going to play you a video that explains how submarines work. Okay, so this is a video that I got from YouTube. I'm going to play this video.
A submarine has a sleek cigar-shaped body that enables it to move swiftly underwater. A pressure hull made of high-strength metal contains the submarine's crew, machinery, and most or all weapons, preventing them from being crushed by the pressure of the water at deep depth. A submarine has tanks built into the bow and stern called the main ballast tanks. The sections of the bow and stern containing the tanks are not usually surrounded by a pressure hull. In order for the submarine to dive, the main ballast tanks are flooded with seawater. The added weight causes the ship to lose its ability to stay on the surface of the water, and it submerges. Movable surfaces on the outside of the submarine control its movement beneath the water. These surfaces are horizontal diving planes and vertical rudders at the stern, and a forward set of diving planes either on the bow or on the sail structure. To dive, the diving planes at the stern are tilted down. As the submarine is propelled forward, the flow of water over the tilted planes causes the submarine to glide downward. The rudders steer the ship. Crewmen can turn a rudder to the left or right to make the submarine change course. To move the submarine upward, the stern diving planes are angled up. The diving planes at the bow or sail are used to help keep the submarine at a precise depth while near the surface, especially when launching missiles or when raising an antenna or periscope above the surface. To resurface, water is blown out of the ballast tanks by compressed air so that the submarine comes up through the water.
And then lastly, we're going to talk about ocean ships and river boats. Seawater is actually denser than fresh water because a lot of salt is dissolved in seawater. So this seawater is a lot more packed than fresh water. Therefore, it is easier for ships to float on seawater than in fresh water. This is why sea-going ships and river boats are designed differently. Most sea-going ships are heavier than river boats. Also, seagoing ships must be careful when entering rivers and need to look at the depth of the river first. Since fresh water is less denser than seawater, seagoing ships will float lower in rivers. And that's basically it for this video lesson. You need to remember that floating and sinking depends on the object's density and also the liquid's density. If the liquid has a lower density than the object will sink. If the liquid has greater density than the object, it will float. So that's the end of this chapter. In the next chapter, we're going to look at forces and Newton's law. So thank you for watching.